Hello guys, welcome to another session of Math. Let's look at this problem. Find x if log of 4 to the base of x log of 4 to the base of x plus log of x to the base of 4 is equal to 2.5. Find x if log of 4 to the base of x plus log of x to the base of 4 is equal to 2.5. How are we going to find the value of x from this equation? Well, if you can, pause the video and try, or let's get started to find out. First, let's write our solution. Now let's bring this equation down here. Okay, log of 4 to the base of x plus log of x to the base of 4 is equal to 2.5. Well, to get the value of x from this equation, we have to apply the idea of what? Log of change of base. Why? Because when you look at this one, the base is what? X, and when you look at this one, the base is what? 4. The base are not the same. And even when you look at this one, the base is what? A variable. This one, the base is what? A figure. So there is no way we can manipulate this to get what? AD figure, or manipulate this to get or anything. So the best way to help find the value of x from this equation is to apply the idea of log of change of base. Okay, so we're just going to pick one base for both of them, and then we use it to form what? A new log with a new base. But how is it going to be done? Well, I'm just going to choose log with a base of 4, and then we will come here, we will pick this number, we use it to form one log, then we divide it by, then we will pick this x, then we use it to form what? Another log. When we come here, the same thing is what? Apply here. Okay, so as I said, log of change of base. So let's change the base. All right, so as I said, we will just pick a new base for both of them, so that we can easily find the value of x. Other than that, we will find it difficult. So to use the log of change of base, that is how it is done. So as I said earlier on, that we will just pick a log with base of 4, and then we just pick this one and we use to form one log. That is what you are seeing here. And then we will just pick the same log with the base of 4, and then we will pick this base of x here, and we use that one also to form another log, and that is what you are seeing here. Okay, and the same thing is applied to this one. That is what you are also seeing here. Okay, so log 4 to the base of 4 divided by log x to the base of 4 plus log x to the base of 4 divided by log 4 to the base of 4. Now here, from the laws of logarithm, when the base and the number are the same, it cancel out. So this one will give you as what? 1. And then when you come here, this one will also give us what? 1. But this one, we'll just leave it as it is. Okay. Good. Here is 1 over log of x to the base of 4 plus log of 4 log of x to the base of 4, which is equal to 2.5. Here I didn't bring the 1 because any number or any variable or anything at all divided by 1 is just the same thing. Okay, but when it is 1 divided by something, we just bring the 1. But when it is something divided by 1, we don't bother bringing the 1. Okay, so now you could see that this denominator here and this one are all the same, right? But still, it's not easy to tell the value of x from here. So what we are going to do here is that we're going to find the LCM, which is this one. Then we multiply it through this equation. Okay, so I'm just going to multiply through by log of x to the base of 4. Okay, Good. Here, this multiply by this. Now I put this one in the parentheses because that will save us the time from just multiplying this, multiply this by this, and later come and multiply this by this. Just going to be a waste of time. So I just did it at once. So that when you open the bracket, both this and this will be affected at once. Okay. So now let's open the bracket. This times this, you could see that this times this will cancel out with this one, and you will left with what? 1. Now this times this will give us what? Meaning this times this one will give us what? Log of x to the base of 4 all squared. Please mind you, this one is not log x squared to the base of 4, no, but it's rather log of x to the base of 4 all squared. Okay. Good. So this is what I was talking about. It is log of x to the base of 4 all squared, and not log of x squared to the base of 4. Now when you write it as log of x squared to the base of 4, you are wrong, meaning this one is what? This squared is only affecting what? The x, but this times this one, the power the square is affecting the whole of this and not only this. Okay. Now 1 plus log of x to the base of 4 all squared is equal to 2.5 times log of x to the base of 4. What are we going to do here? Well, we are having log of x to the base of 4 here, and also we are having log of x to the base of 4 also here. So what we are going to do here is that we're going to do what? Substitution. We're going to find another variable to replace this one. The motive of doing that is that with this telling the value of x will be a little bit difficult, or there is no way we can manipulate this to get the value of x right from here. So I think the idea here is that we should do another substitution. Sorry, we should do substitution, right? So we're just going to do substitution. We're going to find a variable to replace what? Log of x to the base of what? 4. Okay, so I'm just going to do substitution. So we're just going to let y be equal to log of x to the base of 4. Log of x to the base of 4. Okay, so wherever you see log of x to the base of 4, you just put what? Y there. Okay. Now the equation is now 1 plus y squared is equal to what? 2.5 what? Y. 2.5 y. Now let's focus on this side. 2.5 y. Now I hope you all do remember your decimal places. I mean standard form. Yeah, you do all remember that. Convert it from decimals to whole numbers. Okay. So this 2.5 here can be written as well 25 over 10. 25 over 10. If you want to convert to whole number, just look at the first decimal, the number of decimal places involved. Then we multiply by either 10 or the number of decimal places that is involved. So if here the decimal places is 4, it's going to be 2.5 times what? 10,000. Yeah, times what? 10,000. Then we get whole number. But here, what we are going to do here is that this one is 2.5. So we are going to write it as 25 over 10. 25 over 10. 25 over 10. So that at the end of the day, when we convert it back, you just get what? This one what? Back. Okay. All right. Now 25 over 10. This one we can reduce it a bit. We will not waste time multiplying this the LCM through. No, that is why here. Remember, I said if you want to convert this one to whole number, you just look at the number of decimal places involved, and then you just multiply by 10 with together with what the number of decimal places. So if it is 4 decimal places, it's going to be 10 times thousand, that will give you what? Maybe let's say 10,000, and that will give you the whole number. And that whole number, since it's an equation, you have to multiply the whole thing through. Okay, but because we don't want to do that, that is why I change this one to this form. Okay, so that when we convert this one back, we just get this one out easily back. All right, so here we are not going to multiply this one through. Okay, so we are just going to reuse this one a bit before we multiply it what through. So 25 over 10, 5 can go here 5, and then 5 can go here 2. So actually it's going to give us 1 plus y squared is equal to 5y over 2. 5y over 2. Now with this you could see that when you multiply it through, you will not waste another time of what? Reducing what? The equation. Okay, so now let's multiply 2 through. That is the LCM here. So we're just going to multiply this 2 through this equation, so that this fraction will be eliminated. Okay. Good. Now here, when we open the bracket, you're gonna get 2 plus 2y squared is equal to, now here when you open the bracket, this and this will cancel out, and it will give us what? 5y. Okay. Two plus 2y squared is equal to what? 5y. Well, this is a quadratic equation, though it's not equal to 0, but it's still a quadratic equation because of the y squared here. So how are you going to find the value of y? We can use about four or three different approaches: graphical approach, quadratic formula, factorization, and computing square. But here we're going to use what? The factorization approach, because this equation is what? Easy to factorize. Okay, so what you're going to do here is they're just going to bring this one to this side and equate it to 0. Okay, and that is going to give us 2y squared minus 5y plus 2 is equal to 0. Well, so how are you going to factorize this one? Well, to factorize this equation, we're just going to multiply the coefficient of what? Y squared by this constant here, and that will give us what? 4. Then we find the factors of that constant. Then we pick two of those factors, which when multiply will give you what? The 4. But when you sum up will give you what? This minus 5 here. So 4, what are the factors of 4? That when you sum up it will give you this minus 5, but when you multiply it will give you what? 4. That is what? Minus 1 and then what? Minus 4. Yeah, negative times negative will give you what? Positive. And negative minus negative will give you what? Negative. Okay, so here I'm just going to replace this one with what? Minus y and then minus 4y. Okay, all right, now let's bracket. You're going to bracket them, so you're going to bracket this and this and also this and that. All right, so here let's bring the common one out. So what is going to come out? 2 is here, but there's no 2 here, so 2 is not common. Y is here, but the y which is here is 2. Also we have another y here, so y is going to come out. So when y comes out, what is going to be in the bracket will be 2y minus 1. 2y minus 1. Now when we come here, y is here, there's no y here. 4 is here and there is no 4 here, but you can see that this one is 2 and this one is what? 4, but 2 can go into 4, so we can bring 2 out. Okay, so 2 will come out, and here what will be left is 2y minus what? 1. Okay, all right, now here we're gonna pick this and then this one, then we bracket it, then we pick one of this. Yeah, either this one or this one, just pick one. The moment you get this one and this to be the same, just pick those which came out, and then you bracket it and then You pick one of them, then you multiply, then you put it to what? 0. Okay. All right. Now, how are you going to find the value of what? Y? Now, you're going to equate this one to 0. Then later, we also equate this one to also 0. Okay. So 2y minus 1 is equal to 0. Y is equal to what? Now, when you send this one to the other side, or when you bring this one to this side, it will be what? Plus 1. When you divide both sides by 2, it will be what? That is half. So y is equal to what? 1 over 2. 1 over 2. Good. Now let's equate this one, 2, and see what you're going to get. Or y minus 2 is equal to 0. Y minus 2 is equal to 0. So what is the value of what? Y? That is y is equal to what? 2. Y is equal to 2. So the value of y from the equation we generated from the original one is what? 1 over 2 and what? 2. 1 over 2 and 2. But these values are not the solution to the original what? Equation, because in that equation the variable there was what? X and not what? Y. Okay, so we are just going to equate these values one by one to what y was substituted for. Okay, so but y is equal to log of x to the base of 4. So first we're going to pick the first value of what? Y, and then we equate it to what? This one. Okay, so log of x to the base of 4 is equal to what? 1 over 2. 1 over 2. So what is the value of what? X? Well, from the definition of logarithm, x is equal to 4 raised to the power half. 4 raised to the power half. And I hope you all know why is it that x is equal to 4 raised to the power what? Half. Yeah. So what is the actual value of x? X is equal to, now this 4 here can be written as 2 raised to the power 2. And then we already there is half, which is multiplying it or which is powering it. So just multiply it by what? That 2. So it's going to be 2 times what? Half. So this and this will cancel out and to be left with what? 2. So x is equal to 2. So the first value of s from the original equation is what? 2. Okay. Now let's look at the other one. Or log of x to the base of 4 is equal to what? 2. That is the other value of what? Y. So what is the value of what? X here? By applying the same idea here, that is the same definition of logarithm, x is equal to 4 raised to the power 2. 4 raised to the power 2. Now what is the actual value? X is equal to 16. 16. 16. So the value of s from the original equation is what? 2 and then what? 16. 16. 16. So therefore x is equal to 2 or what? 16. 16. 16. 16. 16. All right, guys, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.